Yeah, so the article title is Mind-Blowing. Iron-rich immune cells help homing pigeons navigate. So do you know of the pigeons that can go to the destination without any sunlight or without any light or something?
I think this is an old story that they used to be used for messengers,
Mhm.
and they do go through some sort of human-led training, and these are tamed pigeons, right?
Yeah, exactly. But this article found that the macrophages, which can eat iron in our body, can give a special skill to pigeons to sense the magnetic field.
Yeah.
That's amazing.
It's really cool.
Oh, yeah.
Now, help me remember what macrophages do and why do they specifically accumulate iron?
Their jobs are to eliminate or to clean up, I would say, any waste materials in our body. Red blood cells contain ions, hemoglobin, that can hold oxygen. So that the red blood cells can deliver oxygen throughout our bodies. But of course, the red blood cells are gonna be, tired, exhausted. So we have to update red blood cells to the new one. Then, okay, where do red blood cells go after, finishing their task, their jobs?
Into the macrophage's belly.
Yeah.
Okay. So they are particularly, and the macrophages are relatively long-lived.
Yeah, exactly.
Okay.
Yeah.
So they have a chance to kind of accumulate this iron.
You know what? I'm a pathologist, and I know that phenomena. Like when I see some pathological slide, for instance, in the spleen, yeah, I found so many macrophages containing hemoglobin, which is iron. But we just saw okay, these macrophages have iron. I mean, that's it.
Yeah, no big deal. That's it. End of story.
That's it. So do you think pigeons are consciously aware of that ability to sense magnetic fields?
Yeah. So I was thinking about that, and I don't think there's any reason that they have to know it's happening. And one piece of evidence I would cite is that dung beetles also navigate, not with magnetism, but with the sun or the moonlight. In the nighttime, they navigate with polarized light.
Oh, okay.
Now, do we suppose that a dung beetle is like, hey, time to turn on my brain and start thinking about how I'm using this UV light? I'm pretty skeptical that a dung beetle could do that, yet they're very efficient at it. So I think you don't have to know what you're doing in order for it to be effective. So I'm skeptical that a pigeon knows that they're doing this.
Okay.
So one thing I was reading that struck me was that the macrophages are communicating with the neurons.
Right.
These are macrophages in the liver. There's also neurons in the liver that transmitting the information up to the brain so that the brain can execute some sort of greater function across the whole body. Do you know how that works? How does a macrophage talk to a neuron? I can't really picture that.
The exact reason or mechanisms are, still unknown, but they may secrete some chemicals. I don't know what they are. Maybe cytokines, chemokines, or any kind of molecules can be released from macrophages. Then those molecules go into maybe the synapses of the nerves, and then the nerves can be excited and then transmit the signal from the liver where the macrophages that can give the magnetic field sense to the pigeons, to the brain.
What's amazing is, though, it's not just... If you told me, okay, you're going to release some signals that says you're hungry, okay, that seems believable. It's a general feeling. But this is a signal that says, hey, north is that way. Hey, you're flying this direction. How does a chemical from the liver, a liver cell...
Maybe magnetic field can affect the distribution of the macrophage in the liver. I don't know which part is going to be strong or which part is weak, but maybe the distribution, I would say. Yeah, maybe the stronger magnetic field can hook more macrophages, to the direction in the liver.
Right.
So that it feels like, oh, we have a lot of macrophages in this way, in this direction. So
Maybe there's an algorithm that says something like, you got like this 360 circle, and true north is 0 degrees, and that's got like the most number of signals.
Right.
And if to indicate south, maybe it's like the least.
Yeah, something like that.
Yeah, that would be really cool.
Similar to pigeons, I heard some stories about dogs.
Uh-huh.
When dogs get lost or were, left behind the owners, somewhere unknown, but they somehow could find their home,
Yeah.
and
They're
they come
famous.
back, more than 1,000 kilometers or even more. I don't think that's just a single story. There are many stories, not only in Japan, but in the US or anywhere else. Yeah, dogs should have some special sense to find the direction, and then how salmons can find their home, their original river. Yeah, salmons can smell the the sense of different smells of rivers, so that they can find their home river by sniffing the smell. Okay, it's understandable, but how they can find that direction, almost over like 1,000 or 2,000 more far away from.
Well, I mean, and they must have multiple ways,
yeah.
because just like the pigeons, the study was really elegant. They gave the pigeons an immunoinhibitory drug, and then released them in the clouds, and the poor pigeons got super lost for 24 hours until either the drug wore off or it became sunny.
Exactly.
And then they found their way home.
Yeah.
The pigeons that weren't drugged did just fine, even though it was cloudy.
Right.
And then they also released drugged pigeons in a sunny day, and they also got home just fine.
Yes.
So yeah, they have multiple ways of navigating. Surely the salmon do too.
Yeah.
Surely the dogs do too.
Definitely.
So okay. Did you read this one about the dogs? They poo north-south.
Really?
Yeah.
I had a dog, but I didn't know.
I know, you got to pay attention now. This apparently is their preference, and they avoid east-west orientation when they poo.
Okay.
So try to pay attention when you can. And this is how they orient themselves. When they get lost, or when not necessarily lost, but when they get off track and they want to go back to where they are, irrespective of where they want to go, they'll do like a 20 or 30 meter walk on a north-south axis to orient their compass.
Okay.
And then once they know where they are relative to the Earth's magnetism, they'll come in a straight line.
Okay.
Okay, I've got one more for you.
Okay.
One reason I love these kind of stories is finding out how detection of magnetism has evolved independently in different animals multiple times. In the dog's case, there's sensors that they have on their retina that helps them sort of see the magnetic field.
Okay.
Where the pigeon's one is in their liver.
Mm-hmm.
Cetaceans like whales, they don't only use echolocation, they can also have a magnetic sense. Maybe the salmon do too. That would have been independently evolved because they're completely different lineages. So okay, detection of magnetism has evolved independently, I don't know how many times, at least 5, presumably a lot more than that. That's great. So we might also assume that a habitable planet has a magnetosphere because that protects us from radiation. That's one reason why Mars, for example, or the moon would be so hard to live on, because it's just bombarded by radiation.
Right.
Even if you solved so many other problems, you're not going to make a magnetosphere anytime soon. Like, our magnetic field protects us. So presumably life on other planets has a magnetosphere.
Right.
Okay? Now, that would mean that for the field of xenobiology,
Okay.
astrobiology, we could probably assume that other beings have a magnetic sense. That would be one of the things that they would employ to navigate and survive. So, like, okay, like, now we have another factor in how to imagine what aliens look like or behave like.
I see. Oh, super interesting. So in that case, do you think we can also sense a magnetic field?
Yeah.
Or we just completely lost that task?
I would guess that we could. I would guess that migratory beings probably can. I mean, it's something that's ever present. It doesn't change very often. It's like every 10 to 100,000 years it shifts, and it only migrates slowly. So it would seem to be something that evolution could take advantage of because it's so stable.
You know, a little bit off track, but like insects can also have a special sense to find the direction, like especially bees. You know what? Yeah, they know. Of course, the one more exciting thing is that they can tell, other individuals to the right direction to find the honeys by dancing.
Yeah, it's amazing.
But that's fascinating. Also, that initial story hooked me as well, because two researchers with different expertise.
Yeah, that was good.
Yeah, somehow met in a conference, and they just, started chatting, and then, they coming to the one, collaboration research. What about checking the macrophages?
Yeah, it was a bird researcher meeting an immunologist.
Yeah.
So, like a great story of multidisciplinary breakthrough.
Exactly. Sure. I want to do something like that. But, if I have idea right now, I don't think that idea is great because I can come up with that idea by myself. So the interesting idea, exciting idea should be made by collaboration, conversation.